All right, everybody. Welcome to Cloud Native Security Pittsburgh. My name is John Ziola. We're going to be having a presentation from Christopher here on Cilium. So if you're not familiar with Cilium, you're going to get more familiar with it tonight, and eBPF and all kinds of other goodies. That'll be a lot of fun. So this is a CNCF community group. So if you didn't RSVP through the community.cncf.io, please make sure that you do that. Then you can follow for future events. They don't like it if I don't run an event every 90 days. So that's my goal, is at least to do one every like 60 to 90 days now. And I'm going to be doing these while it is technically Cloud Native Security Pittsburgh. I travel a lot for SANS and for events, and I'm going to be doing events on the road and then some default ones here in Pittsburgh while we're local. So if you're local, keep an eye out. But also, this is streamed on Bevy, which is a part of the CNCF community portal, and it's also live streamed onto YouTube and recorded there. So if you miss it, you can catch up on things later. So that's pretty much it. Just a reminder, there's pizza and food if you're here in the room. I say that on purpose for everyone who didn't show up in person but are in Pittsburgh. Come here, come hang out with us. We've got pizza and salad and bourbon also. So great. So that's pretty much all I have. So I'm going to pass it over to Christopher.
Great, thanks. So before we start off, how many people are familiar with Kubernetes, at least on like a base level? Okay, anybody not? Okay, great. So this talk is going to go very well. I decided to go with the longest title possible just to see if John would complain about it, but it seems to have worked out. This is my intro slide, just who I am. I work for Isovalent, the company behind eBPF and the kernel, as well as the Cilium project, and then more recently Tetragon. Before this, I worked at IBM, where 5 of my 7 years there were contributed to open source tooling. So most of what I contributed to was the SIG network space of Kubernetes. So what did I actually do, and why do I feel qualified to give a talk on network policy? So I wrote a lot of pieces of the network policy API itself. So here, I dedicated a lot of time for progressing network policy APIs itself, collaborated with everyone to work on adding egress policies as well as IP block, and then, adding more testing, suspiciously 3 years later from when I originally contributed the code, but don't worry about that. And then just going through all the motions to get everything blocked. And one of the difficulties I found working in open source was I didn't actually get to see how this got used in the real world. And when I did, I was scared of what I wrote all of those years ago. So apologies if you've ever fought with the network policy API, you thought it was too complicated or anything. That's entirely, well, partially at least, some of my fault. So one of the things that I wanted to look for moving from being a software engineer was to make sure that I never got too far away from what it was that I was working on, that I actually understood how people used the product that I worked on day to day. So that's what kind of landed me at Isovalent, where I work as a solution engineer here. So mostly on like the pre-sale side. However, I have worked on the post-sale side at Isovalent as well. Isovalent itself as well is a company that started even kind of prior to the official start date of like 2017, because eBPF itself was kind of a brainchild that started right around the 2014-ish area. So even before there was a company behind it, of course, the project had to be launched out there. We received, around 70 million funding, and I joined right around 2021. So it'll be 3 years actually on Friday for me. And for Christmas, we got our present of a acquisition for Cisco, actually. So a lot of the last year. So I don't know when that's entirely going to close, but Isovalent has, at least Cisco has intent to acquire Isovalent. So these slides will change in the future. But a lot of deployment in diverse industries. I've been involved personally in a lot of the Bell projects, as well as a few of these. So today, I gave a presentation a couple of months ago at the bar size meetup, which focused more on the Tetragon piece, which was runtime security. Today, I wanted to focus a lot more on the CNI aspects of that. and specifically from the perspective of how Cilium implements network policy. Obviously, there's the generic Kubernetes APIs as they exist inside of the Kubernetes project for network policy. But once you get to a certain point, those become not as expressive as you would want. So the CIDR-based policy gets really annoying if you're trying to query a DNS entry and back it with like all of those different CIDRs. Just trying to have coverage for S3 from AWS, that'd be 7,000 sort of IPs that you would need in there. And you need to constantly refresh those sorts of things. So these are the sorts of things where when we think beyond the core APIs, where Cilium's network policies actually provide a superset of those sorts of values. Why was kind of Cilium born? Why were a lot of the pieces developed? Well, as we started kind of in the microservice world, things became easier to deploy. You gave developers tools that made it easier for them to deploy things. They started developing and deploying a lot more things. So very quickly, there was an explosion of sort of east-west, an explosion of more things coming online, and simply carrying over a lot of the things that were done into the traditional networking world as it relates to IP tables, as it relates to thinking from a hardware-specific point of view, start to fall over pretty quickly. No longer is it just going over to the IP tables person every now and then, asking them to open up a firewall port here and there. You would have to have some sort of unlimited Red Bull supply for the said person if you want that to massively keep up with the amount of churn that you typically see in a Kubernetes environment. So when Cilium was taking off, it was really born out of the desire to rethink the way that we developed these sorts of networking devices, networking systems from beyond the bare metal, beyond the virtual machine days, where a lot of times things are just kind of re-platformed, the same tooling, even in the Linux kernel, was re-platformed, not accounting for the differences between a virtualized environment and a containerized environment. So what tooling like eBPF allows us to do, as kind of a repeat, is actually attach to different system calls or different places within the kernel itself to programmatically instruct the kernel on what we want to do. We don't have to cobble together a bunch of tools to get a desired outcome. We can actually use a programming language, which at its core eBPF essentially is inside of the kernel, to tell the kernel very specifically what it is that we want to accomplish. Two primary eBPF maintainers. One is at Isovalent, that is Dana Workman. Lexi is at Facebook. There's a multitude of other contributors, some at Isovalent, others at Alibaba. But these are the two core people that review things before they make their way up in the networking subgroup, and then finally to Linus. eBPF itself has its own foundation in the Linux Foundation, and these are the primary founding members of said. A little bit of repeat, but what I meant by cobbling together a lot of tools is whenever we wanted to make a connection across to other applications, typically what happens is you're working with NetFilter or IP tables or some other subcomponent within the stack. And these things eventually reach a point where the scale and the churn and the algorithms just don't work anymore. If you inspect actually the output of IP tables, even in a few hundred pod cluster, it looks very difficult to digest. Now you can jump around like 5 times to finally figure out what happens, but the IP table subsystem itself was not designed for this level of progression. Like I said, it was much more akin to someone just like opening up a firewall port here and now. And this leads to also slowdowns in the time that you can bring things online, because you have to sit there and wait until that IP tables list churns through. And this is a very linear search sort of style algorithm. So it takes a lot longer for you to bring things online whenever you're utilizing a system which, in theory, is supposed to make deploying things a lot easier. This is where Cilium comes in by leveraging eBPF. So you have a very specific program for things like process observability. You have a very specific program for service load balancing, applying identity on these, as well as doing any sort of TLS operations. And then you chain these together. And what Cilium actually does is it plumbs these things through the kernel itself. It shares information between all these programs by way of something called a map. Map being similar to any other programming term, is just a key value sort of store owned by the kernel itself. Questions so far on what I presented here? No? Okay, great. So what we're looking to do by programming the kernel to give us exactly what we want is to move beyond a sort of 5-tuple lifestyle, whereby the only thing we're able to tell is a source and destination IP for various things, as kind of noted here. So you get a source, you'll get a destination, you'll get the port, maybe a little bit of information about how many packets were sent and everything. But what this doesn't actually tell you is what went on between these IP addresses. Unless you have a computer brain, you're not going to be able to backtrack and figure these things out. So what we do under the covers is, because we're looking at everything from a kernel perspective, we start to plumb in things from different disparate systems as well. So we can get down to the process that's actually making these network calls itself, as demonstrated by the sort of second part of the graph here. So I know this is a little small, but I'll try to highlight it a bit. What you're seeing here is the actual process that is launched inside of the container, which is known as the crawler device here, which launches some form of a node process. And this logically connects out to what was formerly twitter.com, as well as its own Elasticsearch. And then in mustard yellow down here is everything that happened after that initial execution line in your Docker file. So what we actually see here then is someone, either maliciously or not, got into the kernel and started running other processes besides the one that was initially launched here. And you'll see all of the arguments of that. You'll see also where that went. And that went to definitely not a reverseshell.com, as well as your Elasticsearch database as well, started taking a look at all of the user database. These are the sorts of things that we could programmatically add on once we view from both a process and a networking point of view. So as far as network policies, that'll be the bulk of what I talk about here. And how we do these with Cilium. Very basically, at a network policy level, what we're doing is some programmatic way to apply, based on labels on your pods in Kubernetes, a way of saying what should be able to talk to what. And in this case, I've got a pod with a label of front ends, and I would be applying a network policy to say a pod with the role of front end should or should not be able to talk to a pod with the label of back end in this case. So we'll start at kind of layer 3 here, so right around the IP label, and then just say, very basically, this endpoint, which is a backend, should be able to allow connections. We have ingress here from an endpoint of front end. So what I'm saying is I'm applying this kind of here, and I'm saying this should be allowed, okay? It doesn't mean that front end 2 should be allowed in here, and it makes no mention of what else front end should talk to. It's just saying right here, very specifically, that I'm allowing from this said front end. Now, Kubernetes Network Policies has this interesting defaulting logic whereby as soon as you create one network policy, that is when network policies start to enact. So by default, you're not going to have a completely restricted network policy, zero trust sort of deployment. You have to start creating network policies before the API really kicks in. Now, if you don't have a CNI that enforces network policies, that's not going to matter anyway. You're just going to be filling up your etcd database. In this case, we're using the Cilium specific one, so it is assumed that we have Cilium deployed as the container networking interface. Just a little bit about traffic directions there. And now, as mentioned before, you also have the availability to say what egress traffic I want to allow here. So One thing, and I'll talk about in a second, is Cilium provides a few more things beyond just maybe a label selection or beyond just a CIDR to have logical entities. Let's get past this. And just as I already mentioned, a lot of the rules are based on having an initial policy defined, and you can have empty policies, which I'll show in just a second. Automatic connection default apply does not apply. This was an interesting thing when I was developing egress APIs that there was a bit of chatter about, is if I created an egress policy only, should that also mean that I should start blocking from the ingress side? It was a weird backwards compatibility thing, which you can find the Google Groups thread of me posing this question and then a lot of discussion back and forth. So that is where we came with that policy types thing, if you've ever seen that in Kubernetes policies. So you have to be very explicit to say, I only want, where I want this like blank policy to also affect ingress and egress at the same time, sort of thing. Because like I said, just by creating a ingress policy doesn't mean that I'm gonna disallow all egress, and vice versa from the egress side. Little nuances here, which make a lot more sense when you see the YAML for it. One interesting piece of Cilium here is what we can do is also both keep track of the connection tracker table as well as intercept that. So one benefit to not relying specifically on the contract piece of the kernel is that you can interrupt a connection that is already ongoing. So for instance, if someone made their way into your network, started slurping out an important file, you create a network policy, and that is applied to a system which is based on IP tables. You have to wait till they finish slurping out that file before your network policy is actually going to take place. With Cilium, we would sever that connection immediately because this happens on every packet flow. It has to traverse the eBPF data path. John, question?
Can you clarify what you were saying there about not needing to follow the contract of the kernel?
Yeah, so the contract kernel would be waiting normally on a connection. That's normally how IP tables is thinking about enforcing new logic coming in here. IP tables and the kubeproxy agent, and a lot of these rely on the contract piece of the kernel itself, which means that the connection will, even if you apply a new sort of policy in that system, that connection isn't going to get severed. It's going to see that a connection that already existed and kind of let that go, and you'd have to wait to a new connection before that new policy is going to take place. Does that clarify things a bit?
Yeah.
Okay, but with Cilium, because everything needs to run through each eBPF program attached to TC, that connection can be severed. A new logic can interrupt an existing connection. Any other questions about that piece? Excellent. A few more layers that we're able to find here. So mostly I was just showing the layer 3 piece, but we also have layer 4, which we'll add in now for ports. So you can specify, I want to allow ingress only to this port. So not just like everything, only this one specific port. And I can also combine them to say, I want to allow to front ends port 80 specific port instead of just like all ports on opened up on 80 through all of the pods. One very specific thing that you want to look out for when implementing our policy is some of these YAML trickeries, I'll say, because while this looks kind of fundamentally the same, the boxes are calling out that there is lack of the sort of hyphen here, which means in the first example, this is an OR example. So what I'm saying is, I want to allow ingress from this front end or to these ports, whereas this is anding them together. So just one of these conditions need to match, both conditions need to match. Does that make sense to everybody? This is one common thing that can cause a little bit more friction also in the API, something to keep a lookout for. Now you can also start to wildcard things. The default API, like I said before, is looking for empty brackets this sort of setup. And as soon as you start putting things in the brackets is when it is. But if all you have is something like an egress policy port with these empty brackets, you are effectively now in like a default deny or default allow sort of setup. And the specifics behind what each of those things mean is also in the Kubernetes docs. One other thing that I like to use a lot are match expressions. This is not exactly like a regular expression sort of thing, but it does allow you to be a little more prescriptive to say, as in this example, I want this key of it's app, the operator not in, values app1, app2. So these are the sort of tricks you can play to be a little even more specific with inside of the endpoint. Namespaces. So by default as well, a lot of things are at the namespace isolation zone. So if you created a said network policy, didn't apply the namespace, it's going to be in the namespace and what your kubectl privileges allow you to add in. So if you're currently pointing at the default namespace, you create a policy without specifying the namespace that you want it to be part of, it's going to go in the namespace of default. However, if you're specifying that, or you want to be specific about things in other namespaces, you want to apply on the namespace selector as stated here. Any other questions so far? Excellent. More information about wildcarding. And then here we start to get to a bit more higher level than just the labels. So we have CIDRs in these specific cases, and maybe perhaps you want to allow it to everywhere except for a very specific IP. So even within inside of whatever CIDR you're specifying, you can have exceptions as noted here. I think this exception is really like the API server or the metadata server, like an EKS sorts of things. Now, this is where we start to look into some of the differences between the Kubernetes network policy defaults and what Cilium allows you to do. And what Cilium can do is actually, go ahead.
Could you go back to the first slide?
Yep.
So that 169.254, 169.254 is not always the IP.
Mhm.
In some cases, it's an environment variable that can map to like arbitrary IPs.
Mhm.
Is there a good way to handle that scenario? You would need it to, like,
You
expand
mean
the
like
environment.
this is like a load balancer and there's actually IPs beyond said thing?
No, I mean like
Does it handle environment variables?
yeah, like you. So like there's an environment variable available on the box, which is a dynamic IP 169.254, 169.220 or something. But you don't know when it's going to be before it's deployed. It's only when you get placed onto a server, onto a worker. Would you be able to pull that environment variable and find out what the IP actually is for that? I have different metadata services, things like that. Is there a way to handle that scenario?
I've seen some interesting, like they've been mostly customized controls where they'll land on box and then update the network policy in place after landing on said box. Dynamically inside of Cilium, there's not a lot that we're going to do to introspect from environment variables on that front. So in this case where like you had this, but then you also had an environment variable, which is actually the metadata server, it's only going to apply to this. It's not going to look at that environment variable.
Yeah, that sounds tricky. Like, because if you have like a pod that you want this to apply to, it's across multiple nodes, and the IP is different on different nodes, so you have to allow all of them instead of just the ones that match to the workers, right? That's what you're saying.
Yeah, you'd have to have a rule which included all 4 of those IPs.
Yeah.
Unless it could be expressed by a DNS entry, because then we're going to resolve that, and that will return those 4 unique entries. This is where you can start to shortcut a lot of the things that you would have to specify from CIDRs and whatnot. You could say this to a specific domain name. You can even allow expression matching based on the end dot. So what this would allow you to do is have a policy based strictly on everything that is in the first part here in the first end dot, company.com. What this would not do is automatically allow you to go directly just to company.com. That would be a separate entry. Another important piece to rule out here. So this is going to apply to this end dot directly. Does not mean that all the way down to the company, so subtracting an end dot, that's going to be automatically allowed. So you can be very specific about what you want here. And like I said, this is commonly used for cases where you're working with something outside of your cluster, maybe a database not owned by you, or you're just working with a cloud provider's internal APIs, which can return thousands and thousands of IPs, and they change quite a lot. So what Cilium will actually do is it'll resolve this for you and start keeping track of those IPs on the fly. Questions on these DNS policies?
Are there any ways to, I'm guessing this is no, but I'll ask it anyway, like tag-based policies of like cloud metadata? So
There is something.
same thing like tags or labels or something, or is it somehow tied to that?
Yeah. There's something which I'll mention in a second, which we call entities,
Okay.
where we're trying to expand that to generalized tags that someone could have for their given environment. Like say they have a tag internally that they call like special privileges or something. Then you could say, I want to allow to entity of special privileges, and you've got a matching like metadata policy that says special privileges actually means these things in the background, such that I can write different policies for special privileges as more of a top layer sort of view, but that does not exist today. We do it for some things automatically, like the Kube API server, components of Cilium itself, but not specifically at a customizable point of view. Does that answer your question?
Yeah.
Okay, great. So another important thing that you do want to do when starting to manipulate these is allow to kubedns, because in this previous century, what you would be allowing is yourself to access company.com, but anytime you're trying to access kubedns, that would have been blocked, assuming that's the only thing that you put in there. So often as part of a default policy set, you'll add on at a cluster-wide point of view the ability to access kubedns. In OpenShift, this would be slightly different. It would be probably 5353 that you would have to account for as the port on that. Questions here? Excellent. This is what I was referring to before, where we have these sort of reserved layer 3 identities. Now, some of these are things that we note just by running on those machines. What we'd be able to tell, is this a remote node? Is this my own local node? Is this a host that belongs to the Kubernetes network? Or is it something that I don't know, which I'll effectively just call world, which is kind of the equivalent of a 000/000 sort of setup. So what you're saying here is I want to effectively allow ingress from like anything, basically. So unless I had a deny policy somewhere, I would allow access from anything. Most often you don't want to allow from world, but some people do. So that is why it's in there. Now, how this will change in line with what you had kind of mentioned before is we would want the ability to have custom identities, which you could define. That doesn't exist today. And then moving kind of up the OSI model, we also allow layer 7 policies, which gets even more specific. Not only can you go from the DNS entry, but you can say to this DNS entry, I want to allow very specifically the /path instance over HTTP. And I only want to allow the get method. So I shouldn't be able to post here all willy-nilly. I should just be able to get from there. This makes sense as well?
Can you have multiple methods like in that same line, or do you have to do a whole new line to do another method?
You'd have like another hyphen there for that.
Like you could do method get, method post, method.
Yeah,
get,
yeah.
And you have to repeat the path a bunch of times, right?
Oh, you mean if you want to allow both get and post a path?
Yeah. Or you have
I believe, yeah, this is a list, I think. So you should be able to put comma, post, and whatnot in there as well. Okay. But if you wanted to only allow get on path, but post to path 2, that would be a separate stanza.
You can always do like hosting too, right? But the path.
Yeah, hostname is a part of this API. I don't think that I have a note for it, though. There's also some like header matching that you can do for network policies as well, but I don't think that I have an example of that in here, but it is a thing. Default deny policy, this is an example, as I was mentioning before. If you've just got empty brackets here, this is the equivalent of default deny sorts of things. If you start to put things into there, that's when we'll start enforcing even more so. Baseline policies, these are things, as I mentioned, that normally we have like a zip file for people to consult if they want to apply network policy but don't want to break everything on the fly. We'll have easy things like the metadata server, maybe an explicit CIDR that you're using as part of your pod or node control plane. You don't want to start blocking those things. All of those things could be applied as well, and you don't have to put these in every single namespace, because we have things called cluster-wide network policies, which would apply to the entire cluster. And I'll skip past that. A couple of gotchas in here, as mentioned. I'll have these slides available, but one thing that I did want to call out that does get a little confusing is whenever you're starting to do ingress things from the outside world. If we were to use EKS as an example, you would need to be sure that whatever load balancers or middle boxes in here are actually applying the correct original source IP, either passing it through a header or just not natting it out in order for some network policies to apply. So some people wonder, why is this network policy not enforcing? Well, it's because the load balancer is natting it and the load balancer itself is allowed in. That's kind of a gotcha. Overlapping, conflicting policies, sorts of things. I'll let you just kind of look at this later, but order precedence, sorts of things. There are some CNIs that try to mimic what a firewall does, to have like special rules to say, okay, this rule is actually more important than this other rule here. So they do things like precedence in that regard. We don't do a lot of that in Cilium. It ends up looking very messy as far as the branching and the decision strategy. However, we do allow deny policies. So for us, deny policies are final. If you have a deny policy, that is not overridable even by other people in namespaces that want to allow that. So that is the one level of precedence that we allow, or that we have, not inherently allowing things. How do I make this easier? I don't want to start from no network policies and then have like thousands of network policies. Can you make this easier? Well, of course. So one thing that we have is an editor. This is built in to Isovalence distro, but it's also available at editor.cilium.io for free if you just want to test it out with your given network policies. What this allows you to do is a component which I'll talk about in a sec called Hubble is kind of always looking at traffic as it passes back and forth between nodes. And it'll start to suggest network policies that maybe you don't have an explicit network policy currently covering. And then you can add that into this WYSIWYG editor and download that policy, add it to your CD system, and then roll it out. We won't go ahead and just enforce whatever you do in this editor on the cluster itself. It's really meant there as a tool for development. A friend creates some weird network policy. You don't want to stare at YAML all the time. You want to have some easy way of defining this. So that's what we have here. In newer editions of the API, especially if you have any colorblind sensitivities, what we'll have here instead of just the green and red lines is actually like a check mark or a stop system. Questions about this piece?
Does this do, is it backed by like code commits? Like how does this?
What this is going to do is, right here, I'm looking at all of what my RBAC allows me to see inside of my namespace, all of the existing network policies. So this is my colleague Ray down here. He signed in to the UI, and his privileges allow him to see these network policies within inside of this very specific namespace up here. It's not going to show all of the possible network policies in here unless he has cluster admin privileges as well.
And is this only visibility but not like modification?
Yes, it's visibility. So along the side here, all of these little things are suggestions for further network policies that you can add into this example here. That will update the graphic. It'll show you what the YAML looks like, but it's not going to go ahead and apply that immediately. It'll abide by your normal CD deployment.
How does it make the suggestion?
It makes the suggestions because Hubble is running within inside of the Cilium agent. Hubble is a separate eBPF program that's based off of just observing flows. And so that is how it can tell the identities that are being utilized here, as well as the traffic direction and whatnot. So that's why it suggests things. Yep, so this button right here allows you to create a new one, or that little device there is allowing you to plumb up your, and it doesn't need to be a network policy that is going to apply to the cluster that you're currently looking at this in. I use it a lot, like I said, for someone who creates some like random thing and I want to know actually what it is without having to introspect all the hyphens and indentation and everything. I'll throw it in here and then it'll show me very specific what it's trying to access.
Are you able to like simulate a cluster, like design a fake cluster in here and then apply a policy and see what would happen?
There is a mode of Cilium policy enforcement that exists in the open source stack, as well as the isovalent one called audit mode. And what this will allow you to do is apply policies, and then Hubble, the observability tool, as I mentioned, is saying was something allowed or denied. In a case where you've set the policy enforcement mode to audit mode, instead of saying allowed or denied, it says audited. And that would be a flag to say, hey, you have a network policy that is applying here. We didn't actually block it or anything, but it would be blocked if you were running in policy defined mode. Now, in the future, Isovalent as the company is looking into, there's a component that backs a lot of this called Timescape. It's based on a ClickHouse database. And it will take a new network policy and then show you all the cases that it would have applied based on your historical sort of data here instead. That doesn't exist today, but that is kind of the future thing that we're working on. It's an often requested feature.
So this is live hooked into like,
This is live, yeah.
how do you handle like multi-cluster management?
That is where we're going in the next set of slides,
What
actually.
about the opposite? What about no cluster? Like I'm designing a cluster or I'm envisioning a cluster for the future that doesn't exist yet, and I want to see what the policy might look like and kind of play around with things.
Yeah, so you can upload just some random policy, or you could go to editor.cilium.io, like right now, start crafting a policy, and then you'll get this sort of visualization as well.
Okay, yeah, that makes sense.
Now, if you start, like a lot of people will do like a mix. Like they'll start with our default policies that say things like, allow Cilium to talk to its other Cilium components, allow things to query kubedns, allow Cilium to talk to the Cube API server, things like that. And then they'll either use these suggestions, they might experiment with audit mode as well. It's normally like a mix. Network policy can be kind of like a heavy hammer to swing in an existing cluster. And that's why we allow kind of multiple options to start enforcing those. Other questions? Okay. So I mentioned Hubble just briefly. So eBPF programs are kind of stacked up, and one specific eBPF program that we have that the Cilium agent also manages is called Hubble. And Hubble is taking a look at the sort of network flow systems and aggregating this in a cache, and then the tooling aggregates that across different nodes. It reads from that cache, and that's how you can get a cluster-wide view of what's happening, not just one individual node. So there's a component that's owned by the Cilium agent as well. It's a separate eBPF program that's based off of looking into it from more of an observability point of view, not necessarily like a traffic or packet decisions. Does this make sense? So it's a program that exists on all the nodes, and then the UI kind of aggregates across all of the different nodes from that perspective. And here's kind of what it looks like. So this is a very basic call out. Because we're able to introspect DNS as well, we can take a look at what did this very specific pod in the default namespace call out. So it made a connection to the outside world to Disney.com, and we're allowed to grab that sort of thing. There's different places in the stack, to endpoint. There's great documentation for what this actually means, but at its core, it's at what place are we enforcing this? Is it in the container itself? Is it in the host network namespace? Or are these things that are happening in the layer 7 proxy that we have? Those are different pieces where 2stack, 2endpoint, where it's just telling you at what place this is actually functioning at. Now, all of this information can be dropped out the JSON to some external system, as kind of mentioned here. You could throw it to a Loki stack, you could throw it to Splunk, you could throw it to an S3 bucket, just to have it for auditing purposes. This often is used for one, creating dashboards for very specific things. Like I want to know all connections to Disney.com or just any DNS entry that lives outside of my cluster. And then maybe I want to have the full unfiltered thing sent to an S3 bucket for auditing purposes, compliance reasons, things like that. Obviously, this could get quite chatty. So there is ability to tune it, allow for sampling, allow for, I don't care about this one namespace that's particularly chatty, so don't log everything from that, or drop every so often, give me an aggregated view, give me a point in time, those sorts of things.
What are the sampling options?
Uh,
Like, are you just saying like a percentage, or can you do something like hyperlog log or something?
yeah, there's a percentage. There's also based off of like, do you want to see both sides of the connection, or do you want to see the aggregated connection? So it's verbosity a lot in terms of that. One of the things that we do strive to do is not drop events, because we're directly in the data path here. You can easily start to put a lot of memory pressure on your box if you're trying to collect everything. So that's why some of these filtering and aggregation options also exist. And then all of the metrics, another piece of Hubble is deploying metrics on in a Prometheus compatible format so that you can see what specific pods are having problems. Do I have some specific pods that are having denies, whether that be an issue with a network protocol not being allowed, or a network policy perhaps that's dropping it. And that's where you see a lot up here. Policy denied. This could be like the actual policy as is in this case, or it could be you've got some IPv6 turned on, but your network doesn't allow it, so it would show a different drop reason. In that case, it'd say something more like a protocol drop reason. Another thing that we do, and this kind of relates to another component which we won't talk too much about, but called Tetragon, that can take a look at things existing outside the cluster and start to introspect more than just a raw packets push through. We can do things like see how many retransmissions, which is especially useful for things that you don't own. So you can say, is it my fault, or in this case, is it Twilio.com's fault? And on what side of the connection is this failing on? Does it help you to get Twilio.com online faster? No, it does not, but at least you know on the side that exists. So this is combining together a bunch of different metrics on that front. And you can also do this in terms of like latency. So I'm hitting a lot of latency out to this specific AWS service or this specific integration point that I don't own. Another thing that we've been experimenting with on the OpenTelemetry side is actually having traces. So under the covers, we run an envoy per node, not as like a sidecar existing on the thing. And for traffic that we can push through that envoy, we can also start to collect and add in metadata for traces. So in this case, we're taking a look at a few distributions here for requests duration for this given source. And then we can take a look at that with Tempo in this example, Tempo part of the Grafana stack. And we're seeing a trace here of all those various pieces. Questions on the observability front here? Another very specific.
Something like a malicious IP or like an external dynamic list of some sort. Like you maintain something from like Pro, would you be able to say like, oh, all of a sudden it reached out to this IP that it probably should?
Yeah, this would be more on the Tetragon piece, something that's designed for that process and more security enforcement from the process standpoint and matching things outside the system. You could have a controller that makes network policies out of that. But I would say that that's more in line with our process visibility component called Tetragon. I gave it, were you at that talk? I'm guessing not. I gave it at the bar side. I could send, I think he publishes those, doesn't he?
I don't remember if he was able to record that. But
Okay,
I think he
okay.
had some AV issues.
Well, every 90 days, we need to give a talk, so we could talk about that next time. One important thing that people have been asking for a while is, okay, Hubble will tell me when a network policy does this. I want to know explicitly which network policy it was, because I've got hundreds of network policies. It doesn't help me just to know that a network policy did it. So this is a fairly recent addition, Cilium 115. It'll guess explicitly which network policy it was, so you can chase down that problematic network policy. Click too soon. Another thing is this Hubble redact. So, okay, I can grab a lot of the headers and whatnot, but I don't want to apply that to that JSON log you were talking about and then export that to some system if it's a particularly sensitive header or anything. So another thing with 115 is the ability to redact certain things that you do want to be logged by Hubble, things that you do not want to be logged by Hubble, whether you want to drop those or just kind of redact the value as shown here. Questions on this piece?
Does it automatically do that, or you have to configure it?
You have to tell it that you want to redact. By default, it's going to collect all of the headers.
Cool. So that's something like every developer will mess up.
Possibly. Yeah. I mean, I feel like that's just kind of how it goes because headers are a thing of the protocol, but what you shove into those headers are really you as a developer, what you want to throw into those.
Well, I just meant, I was thinking specifically like authorization header, like where it's like pretty clear, like we know what an authorization header is.
Right. Yeah. I mentioned sort of
Like
these
those bodies and
default
bodies.
sort of policies that we have. Part of those are things like authorization headers where we start to, like if you were to engage with Isovalent, we would provide some of these known things that you would probably want to scrub out. But as an open source user, that's kind of up to you. The tools are there to allow you to make good or bad decisions. To be very prescriptive about some of these things, and I mentioned this as well in the previous Tetragon talk, is okay, I've got an unfiltered JSON log of all these things, but what if I want to create some pretty dashboards to actually do something with that so that I can have my NOC look at, or my security operations center, or just I want to be able to prove that I'm actually implemented any of those FedRAMP requirements or anything that have come up. So I want to take out any particular TLS versions that are not particularly well, that are basically compromised and useless in today's world. And also in cases where those are still being used, I want to see where they went. So this is a very specific dashboard, taking a lot of those samples and then just presenting it in a more useful, consumable way. Other things, so someone wanted to note an anomaly in this case. They wanted to be able to detect inside actors, potentially people that were employees or contractors or anything that were slurping out huge pieces of data that seems not to be in line with what the applications normally should do. So I showed that example where someone execed in and started netcatting something out. If you wanted to do that kind of in a more dashboardy way where you don't have to see this explicit thing, you want to know how many bytes roughly are sent between applications. So this is a very rather trivial example. So in this case, what I did is I ran an apt pull down, which obviously shot up the number of bytes that I would be receiving and pulling down a whole bunch of binaries. But in a more nefarious case, what this could also show is that I was pulling down or sending out to a very specific endpoint, and the byte limits got tripped in this case. It's an anomaly, and that's why I'm flagging it very specifically with the red colors here.
I just want to make sure I understand. It's not necessarily flagged other than you created a volume change inside of the Splunk dashboard. You're not doing like entity analytics that this suddenly has changed. You're just saying there's a lot of difference here.
That is correct. Yeah.
Okay, I'm just, so, but your other product that you were talking about, the runtime observation platform, is it capable of seeing or flagging that type of sudden change in activity?
Yeah, it is the thing that is going to be reporting on this, and it can also report on it as metrics to make it a little more obvious. It doesn't have to be just whatever you crafted in Splunk itself. If you were to move,
I can write similar rules against that to say, okay, if I see a 50% drift here and flag it.
yes, yeah, we've got watermarks for those things. So you'd say, hey, a threshold has been crossed. Start to flag this. Create like some big event that gets exported to say like danger, danger, danger here.
Then not to belabor this question, but also, do you have an orchestration capability where I could then take that and apply a network rule?
Yeah, you could apply it at the process level. You could apply a network policy.
Or neuter, or excuse me, meter or block a network policy.
Exactly.
Okay.
Yeah, that's where Tetragon moves beyond observability tools like Falco, which have rule sets and will alert on these sorts of things, but then won't take that extra step and then allow you to craft a policy to start blocking those. So this is something that Tetragon does do. And if you're interested in a deep dive Tetragon, happy to set up a session later on.
We didn't get invited to the bar side. So.
Yeah.
Or else we would have been there, obviously, if you met us.
So wait, so Tetragon can like take response actions and like kill a pod or a container?
Yes. Yeah.
And is it orchestrated back to Cilium or the original product?
Cilium itself is more concerned from the networking point of view, and it's observing things at the transmission control layer in the Linux stack.
Yeah,
Whereas Tetragon looks at it from the binary perspective, the whole node.
But can it write, I guess what I'm asking specifically, can it write then policy?
Automatically?
That was the question.
Automatically, no. But if you look forward to Cisco's acquisition, you can see probably where they want to plumb in some of that. Yes. I can't confirm or deny those things like legitimately because I'm not part of those conversations. But yeah, as an outside user, I can. That is part of the big. Yeah, I mean the security group is very interested in the capabilities of Tetragon. Cluster mesh, and this will be the kind of the last. I've got, as always, I put like hundreds of slides in here just to have in case nobody asks questions. But thank you all for asking questions. So we've been pretty good. Go ahead.
So the product, all the applications that you've been talking about so far, are they independent of Cilium? So can I use Tetragon and Hubble without Cilium?
There is a case where we've been working on like a Hubble beyond like Cilium as the CNI. It's being researched. Tetragon, the answer is very straightforward, yes. So GitHub is a public user of Tetragon. They're not deploying Cilium as a CNI. They just wanted it from the process standpoint. So everything on GitHub servers, they just install Tetragon as an agent to observe process visibility. At a certain point, a lot of the tooling out there, like there was that one from Facebook for a while. It allowed you to kind of query your whole sort of network. OS query. OS query falls over, and then you want something to be both a little more scalable and also then take that and apply policies. They started to hit the limits of OS query. They wanted something else. They chose Tetragon. So Tetragon on its own can run independent of whether it's even a containerized system because it looks from the host standpoint. It doesn't even need to be in Kubernetes itself. Other questions? Definitely can see a Tetragon presentation for this group coming up in the future.
Well, you can invite us to bar side.
Or we can find that bar sides one. Because it was asked, this will be the last thing that I want to cover here, or else we'll be here all night. How do I do this across clusters? So one big feature of Cilium as well is the ability to kind of flatten a network, not require you to pass through transit gateways or external proxies or things. You want to treat one cluster as its own failure domain and have things that exist in other clusters equally the same way in terms of network policy. If you're throwing on encryption, you want that encryption to work across two different clusters. And that's why cluster mesh was designed to make sure that operating two clusters is going to feel very similar to operating one cluster. How this works is you create something called a global service. There's no need to create like 3 other different types of CRDs to accomplish this. You have to create a service for the thing to be exposed inside of your Kubernetes cluster. And the only thing that we ask now is for you to add on that you want this to be a global service. From that point on, backend will be searched for in all clusters that are now part of effectively a mesh. Unfortunately, we overuse the word mesh. So if you look at the website, you'll see a lot of instances of mesh. Very specifically, when we say cluster mesh, we're talking about combining together 2 Kubernetes clusters that are both running Cilium in some capacity. So what does this allow you to do? For the first case, maybe you're just stamping out for high availability reasons. You've got cluster 1 in region US East 2, and cluster 2 and US West 1. And you want to have some way of failing over, either only in cases where the local backends are available, or just round robining between, so that you don't have to have that sort of active passive. You can actually utilize those resources. They're deployed, they're running. Why not round robin between them if latency isn't a concern? So that's what the first sort of use case for these global services is. And what this allows you to do then is any backend as part of cluster 1 and cluster 2 was equally treated whenever some front end in either cluster is trying to fetch a backend. And then in the case of the local cluster's backends going away, you'll fail over to only reach out to the backends in cluster 1. Does this make sense to everybody? Now, even within inside of these, cluster is a label that we're adding to individual pods and everything. So you would be able to say as well, maybe you've got a third cluster, and while it is meshed with these other 2, you don't want cluster 3's front ends to be able to talk to cluster 2's backends. So you can have cluster be a label that you can enforce network policies on as well. The other use case for global services, maybe you've got a team that owns a very specific service. They don't want to deploy that service in every single cluster here. So we call that kind of like a shared services cluster. And I use Vault here as a secret storage as an example. So the Vault security team only wants to deploy in their special Kubernetes cluster. And you basically want to create a pointer record in these other clusters to say, whenever I need to access the Vault service, go out to this external cluster. And then the important piece here is that because I can kind of condense that here, cluster 2 can go away, and that's not going to affect cluster 1 at all. There's also no proxies between here to tell it those things. This is just a flat layer 3 sort of network. Questions on this piece? Right. As I mentioned before, there's also these little annotations you can put in here for whether you want to specify that I should prefer my local connections first so I don't get charged egress costs before I file over to the other cluster. Or you can also have remotes. That would be more of the use case of this, where you're saying, I never am going to have these endpoints locally. That's always going to be remote. So it's just kind of a shortcut thing. Where this gets really interesting is when you start to stack up additional capabilities of Cilium from the ingress perspective. So what you can do is start traffic shifting inside of a given cluster for these given front ends, but also still include all of the backends across the cluster. So now you can have even more parts independently fail in different clusters and still be able to access components that aren't failing. Does this make sense? Excellent. So in this case, what I'm saying is I want to send 20 from the ingress perspective, because Cilium can act as an ingress controller. 75% of the traffic goes to cluster B, 25% goes to cluster A. I'm doing this normally as like a canary rollout sort of thing. I'm not specifically canarying backends, so I still want to include all of the available backends in this case. So just combining together a few different features inside of Cilium. And the other piece is this is most often used in cases where there are sensitive deployments. Because you have like a flat layer 3 network in this case, you can also spank on some way of encrypting between those pods. We do IPsec or WireGuard. IPsec is where you want to go if you have any compliance or FedRAMP requirements, because WireGuard is not FIPS compliant. So what we do here is, if you're familiar with FedRAMP, there's Security Control 8 and Security Control 11, I believe. One specifies the transit mode needs to be of type IPsec or TLS or something like that. And then the other piece, which is, I believe, the Security Control 11, you have to have a special module that you look at in the there's like number CVMP or something. And the module for us is just actually the operating system's crypto module itself. So if that's Amazon Linux 2 crypto module, that's Ubuntu Pro, that's Red Hat, all of those various things. We don't have to lump in an OpenSSL library because all of that is being done by PSEC, which has been known and used for longer than I've been alive, probably even. So that's what we were using for that transport piece. And then the ciphers and everything come with that second security control. So this allows you to have encryption between two different clusters. They can share an intermediate key and everything in that case. And it's just some minutia. In the description, I mentioned a few other like BGP things that I want to allow, but we've already been gone for an hour here, so it might be good to kind of stop with what was presented so far and maybe leave some of the more advanced load balancing stuff to another discussion. I could try to summarize in 10 minutes, but
Sounds good to me.
everyone good to
No
stop?
one's asleep, so
Yeah.
yes.
Okay, so you want me to keep going or? I could start with some of the load balancing because these are things that I'm quite passionate about. So one thing that's very common in a load balancing scenario is you normally have like several layers to your load balancing tier. You might have a global load balancer and then subsequent load balancers distributed in different regions. And failures between any of those middle boxes along the way can cause a connection reset, which is most often the case if you're looking at a randomized mode, especially in something controlled by kube-proxy. What Cilium is able to do is take on the role of kube-proxy such that you can delete kube-proxy, no more IP tables coming from kube-proxy, and rely on SIM alone to make service load balancing decisions. So how this plays out is we can actually choose a specific algorithm known as maglev. There's a Google paper about this. It's a hashing algorithm that's a lot more specific to these sorts of failure modes, and allows you to resume connections even from a machine that may not have served the original request. So what that looks like in a normal example here is I, as a Rubik's Cube, am going out and I'm hitting this load balancer and I'm getting bounced to this given backend. You'll see this quite often in the Kubernetes case where ingress points you at any number of nodes because any node can handle a request, but it might not be serving the backend. So kube-proxy kicks you over to a node that is serving the backend. This use case makes sense to everybody? This is just like a core feature of Kubernetes. Is any of these nodes are available unless you're starting to use those prescriptive load balancers that are sending you directly to a node from the load balancer, which in this case we'll not get into. But if this intermediary node, so in the Kubernetes case, if this node goes away during this existing connection, what's going to happen is Rubik's Cube is going to notice this node is not available. So it's going to go to this agent, and then this new worker node is not going to know about that connection. So it just tries to forward you to a new backend. However, this new backend has never seen this before. And you're trying to send more data. The TCP connection hasn't been established before, so it's not really going to know what this was. So it's going to reject it and say, I've never seen this connection before. Go ahead and send a reset back. In the case of maglev, and this has existed for quite some time in Cilium, what you will be able to do is go through the same scenario. Because there's a shared hash table between all of these given backends, even when you come here to a new middle box, it would know that this connection would have existed based on a shared understanding and be able to route you back to the backend that you had chosen before. Does this make sense? This is like a huge deal in the load balancing space because like these boxes burn down all the time, hardware fails all the time, Kubernetes nodes fail all the time, especially.
Sorry, where does the information go though? Like where is it actually stored?
It's stored in for us it would be a map. So there's a shared table. The paper goes into a lot more detail about how the algorithm actually works, but essentially there's a hash map that exists on all these boxes such that based off of the connection table, it would have known that if a connection existed before it was saying that it was part of this connection, I would know that that logically would have gone to this backend.
Oh, it's like predictable. Is that what you're saying?
It's not really predictable. Yeah, I mean it's predictable in the sense that the table is shared among the nodes, so it's not like guessing, but it's like a shared understanding of the connection table instead of just an individual localized understanding.
Synchronizing a table across the nodes.
Yeah, there's not like a controller that synchronizes. Well, there kind of is if you consider like the Cilium operator. But I think explaining the inner workings of the maglev thing might be beyond the scope of this media presentation. But I could point you to the,
Yeah, I'm just interested.
yeah.
It would basically ensure then, like, ensure stateful connection regardless of whether or not the underlying node went down.
Exactly.
Your stickiness.
Yep. Another interesting thing that we've done is in terms of rate limiting as well. So rate limiting as well as congestion control, which is a huge thing now that more and more of the world is becoming connected. Not every broadband is of equal strength. And oftentimes you'll hit cases where you need to be very specific about your sort of congestion control algorithms, your pacing, because they're not all logical. And I'll play out a little bit of what that looks like. So what we want to be using is something called the earliest departure time, EDT, another paper from Google folks on how to give fairness to different packets as they route through the system. So let me get to a graph here. So normally what we're using is something called Cubic. We're using also a shared message queue for a lot of these things. So an annotation existed for a while in the Kubernetes space to be able to control bandwidth. What this uses is sort of a more shared queuing thing. So because we could be very prescriptive about this interface is attached to this pod, and your call is being made to said pod, and we don't have to have a shared bridge sort of understanding, we could take advantage of a lot of the hardware itself in order to also make for fair queuing. So let's get back a little bit of the issue. So as far as congestion control 2, we're able to sub out from the cubic understanding such that whenever there is a sufficient packet loss, whenever the pipe returns to a steady state, we can get back to maximal sending as well. And this is demonstrated in this case where we're using the cubic congestion control algorithm. We're sending pings back and forth between two different endpoints. And what you notice here is we start to hit congestion where how this normally happens in the Linux kernel is it ramps up and up until it hits like a maximum. And then if there's any sort of problems, as noted here, it goes down, it halves itself, and then slowly works its way back up to its maximum bandwidth. If you can sub that out to a congestion control known as BBR, it stands for better bandwidth rate limiting. What happens is using a same sort of method, we start at 200, we ramp up, and then we start to hit a little bit of a problem, but immediately we're going right back to the maximal connection very quickly. So this is both a more aggressive retransmissions happening normally in the BBR scenario, but how this becomes a lot more visible is if you were to take a YouTube video and you had a lot of congestion. You're used to seeing the HD, all of a sudden you hit a lot of like constrained bandwidth, drops you down to a low resolution. And it takes time before it'll automatically transition back to that HD. A very clear example of this I showed at KubeCon in Valencia a few years ago. So I'll send a link to that. I have an example of taking the same video and applying congestion to both machines. And then you'll see in the example where we're using BBR, we're able to persist an HD sort of connection the entire way. Whereas in the case of using Cubic, it's blocky. It starts to go back to HD, but then it drops down. So there's different tools that we're using to simulate the congestion. It ended up being an ordeal because, as with most conference Wi-Fis, that adds on congestion itself. So I'd do a lot of remote machine setup in order to get around that, because the example is based on congestion. And if I can't predict the congestion, that gets even more confusing. But I'll put a link to the example. So video is the most common thing for this, but you can also think of call quality as well. You don't want to necessarily like replay back in time everything that someone said. You might just want to take the last thing that they said. A lot of underlying details. And then here's where we get into some of the load balancing pieces. So another thing that people have been wanting for a bit is Cilium used to link directly into MetalLB from the kind of like a library use. We used to deploy MetalLB. And one of the missing things once we started to implement something more with the Go BGP library was the ability to have layer 2 announcement instead of requiring BGP. So this is something that came out in our last release. So now you can do layer 2 announcements and not have to deal with BGP if you don't want to. And this also extends to load balancing. BGP, we allow various BGP settings here, and there's 2 different sort of versions here. I'm going to point you to the lab for a lot of these things so that you can see how we can take advantage of graceful restart and things like that. The Caligo project from Tigera has existed for a little bit longer than Cilium, and BGP is kind of their core bread and butter for how they make these route decisions and whatnot. So it's been a bit of a catch up for us just to slowly adopt a lot of the BGP things, but we have some specialized developers that have joined the team, people that have made, worked on huge systems at Line from Japan. And that's where a lot of our BGP understanding is starting to improve, and we're getting a lot more specific about what we're going to allow. So most recently, MD5 authentication is something that we added in as well. And BGP community support in the same release was also added as a way to also have various labels on that. There's other things that take advantage of this, which I won't get into today, but we've also started to develop from a just software-based load balancer, not CNI perspective. How could we take advantage of Cilium's high-performance data path to replace things like Nginx or other software-based load balancers? And BGP community is one of the things that is important in there for distributing these routes. The last piece that I'll mention is the multi-pool IPAM mode. So once you start to get involved with BGP, you also oftentimes start dealing with multiple IP address management pools. So if you want to assign a pod from X or to X, you want to assign from this specific address space versus that address space based on labels. This is very important for cases where you're working with like a telco who are constantly growing and have overlapping IP address ranges, and you need to be specific about how many are allocated from this or that, and also which ones you are allowed to add. How many have you doled out? How close am I to exhausting it? So this is a kind of a more advanced feature, but something necessary for larger, especially on-premise environments. I do see BGP sometimes in cloud environments, a little less so, unless you're doing like serving a lot of requests through your core logic and then spreading out to different cloud providers. That's where I see BGP being used in cloud environments. But certainly, if you're all on-prem, there's top rack switches speaking BGP somewhere. That's it. Questions?
Yeah, I have a question. So in terms of like the stuff you showed earlier with the policies and stuff that people would create for communication between devices and whatnot, how do you typically see that being managed at an organization? So, like, Department A might be doing something, and then Department B might need to do that as well, interact with it or interface with it. Seems like a lot of moving parts in large organizations to like try and like tackle that. Maybe in a small organization it'd be easier, but I'm curious to know your experience there.
Yeah, so what we're often seeing is the team that owns the Kubernetes platform, that is the infrastructure that makes up Kubernetes, as far as the CNI, owning the control plane if necessary, if you're not using a managed control service. Basically, the people that get paged whenever it's known to be a Kubernetes problem are some of the first people that start creating network policies. And they might not have insight into whatever the hell someone deployed out in the cluster, but most often they don't. This is where cluster-wide policies start to come in, where you can be a little less restrictive to say, I don't want to just apply these to everybody. Maybe I want to open it up a bit for some period of time to allow them to start to create their own network policy. So I'll have a cluster-wide network policy, not specifically namespace scope, to say, allow all communication inside the namespace, which most people are allowed to do. And then if they talk to things in other namespaces, they can normally note what those things are. So you'll start to add those as part of your core network policy rule set, and then either utilize Hubble, as I was showing in that example, or turn on auditing mode for a certain selection of things, and then just have it flag audit mode. And then you start to develop a corpus of knowledge about pieces. So you can, at some point, have seen all of the traffic for some part in time, so you do have an understanding. I think that editor.cilium.io, or if you're using the enterprise version, it's embedded directly in the enterprise UI, is where most people want to move towards if they want a more visual way of doing this, if they don't want to take up a whole bunch of time, because that will start to craft the policy for you as well. Does that make sense?
Yeah, it does. Is there anything open source or not that does like some sort of learning aspect of, okay, I see this traffic communicating with this, and then recommendations for policies to be created?
The learning is based on like live data, as I was showing in that example. We don't have any Isoveil is mostly made up of kernel engineers, which are not very good at AI or ML related tasks. And therefore, we as Isovalent have not had the expertise in AI to apply some of those systems. But looking forward to seeing what Cisco can provide on some more of those automation things. So for us, the live traffic, like things bouncing back and forth currently, are what we can show. But if you want to be a little more predictive about those sorts of things, or even automate it without any human involvement, that is a future facing thing.
Yeah, there was at like 2 KubeCons ago, in the Cloud Native Security Day, like before the event, there was a talk from Microsoft on exactly that. And I think Microsoft is a little bit better positioned like in that space maybe to check out what they're working on. Yeah.
As you mentioned, Microsoft, Cilium is agnostic to cloud providers and whatnot. In fact, some cloud providers have chosen Cilium as either the preferred CNI. If you're going beyond simple pod-to-pod routing, that is the case with Amazon. In the case of Microsoft, now whenever you create a new Kubernetes cluster on AKS, you can choose to click a box to say, I want to use Cilium and have that managed as part of my deployment. The Google case is they have like a fork of Cilium, which they call ANetD. So if you create a cluster in GKE with data plane v2, that is Cilium under the covers as well. But any of the cloud providers, we have integrations such that you can mimic whatever that CNI is doing as far as IPAM or VPC routing. So you can mimic exactly what the VPC CNI is doing in the Amazon case with Cilium. You can chain, as Drew was mentioning earlier, or you can delegate all of that to Cilium such that Cilium will do VXLAN or Geneva encapsulation and also handle any IP address management outside of the cloud provider. All of those options are available.
There is a question from online. So Austin says, right now I'm using a bunch of Docker containers with Redis, Tomcat, and Postgres. I use Terraform to stand up infrastructure in the cloud. I execute a bunch of attacks on our environment, and then I tear down the infrastructure. I saw on LinkedIn, John mentioned, if you don't need to use Kubernetes, then don't. At what scale does Kubernetes become relevant?
That's good philosophical. I don't know if that translates directly to a Cilium question per se, but I mean, I went through this sort of thing at IBM, where we got to a case where we started to adopt a lot of the Netflix tooling. So Watson was where I worked at before I started working on open source stuff, and Watson traditionally was run as a shrink wrap software installed inside of your data center on hardware that you owned. Then it came to the point where we wanted to offer Watson through SoftLayer as a cloud deployment. And we started off with the normal, we had to, of course, take a lot of the Netflix tooling, which is AWS only, and adapt that to SoftLayer, what became IBM Cloud. And we used Asgard, we used their service discovery system. Eureka was the first iteration of that, if anyone remembers Eureka. And it got to a point where deploying VMs just took too long, as well as capacity-wise, oftentimes people would overestimate how successful their service was going to be. So they would have a lot of stranded resources out there in their VM world. So maybe their service really only takes up like 2 vCPUs and 6 gigs of RAM. They would say that I need 10 vCPUs and 32 gigs of RAM because I might, pop off and all of a sudden I'm going to need that. That became untenable at a certain scale because while we could rely on new VMs to come online, that didn't do a good, that wasn't being like a good internal user of SoftLayer. So SoftLayer had to over provision a lot. We would be stranding a lot of system resources out there. And at that point, we considered a containerized deployment. And at the time, this was 2014, I made the decision to go with Mesos because Kubernetes wasn't super popular at the time. So we were using Mesos for a while for services deployed through the Watson cloud. And that was a significant advantage. Now, Mesos didn't have the good Docker store they were looking for. So eventually the Watson cloud did move over to Kubernetes. But I would say eventually when you hit those cases where you deploy an EC2 image and it's taking 15 minutes and you need to serve Pokemon Go right now, a lot more people are going to start running into that once they hit a certain scale. And we hit that at IBM, within the first couple of years of trying to deploy out into the system. So I would say the resource stranding is a big thing. But I take the point that Kubernetes can be quite of a bear that I helped it design.
Yeah, I definitely try to recommend if you can avoid it, do so, even though I'm a huge fan of it. And the way that I see that kind of tipping point usually has to do with like data locality. You need to keep the data local for some reason. And there might not be a AWS or cloud data center or whatever in for instance, the Canadian province that you need to do things. A lot of Canadian provinces have these data locality requirements, and there's no data centers there. They also have like all kinds of crazy laws, which are like impossible to actually implement in the real world. So I'm not a huge fan of Canadian regulations. For instance, like communications between provinces needs to stay within Canada, but literally the backbone of the internet comes into the US and goes back out. So I don't know how to route that unless you're going to run your own wires, things like that. So yeah, the data residency is one. The spiky workloads that you were talking about is definitely one. Scaling up, scaling down, like the Pokemon Go. Or if you want a really unified developer experience across multiple clouds or environments. You get that kind of like unified API of Kubernetes for how you actually do CI/CD. If you want to do it into the cloud and then into a data center on-prem or something, it's usually, that gives you that like similarity across those environments, and that's pretty useful too. So, or just actually needing like the high scale of a Kubernetes cluster, which is, I think, the most obvious.
Facilium was designed to work independently of if you're using Kubernetes or not. So you can just deploy Cilium as a generic network policy agent, and assuming everything is running in uncontainerized mode in the host network's namespace being a kernel namespace, not a C++ namespace or Kubernetes namespace, just at that privilege level inside the Linux kernel, whereby everything is running in host network mode. Cilium can still enforce based on, we call those a special type of network policy called host policies. So you can get advantages of a containerized deployment with network policy, even in an uncontainerized setup.
Awesome. Any other last questions? Cool. Well, thank you, Christopher. Really appreciate it. Let's give him a round of applause. So that pretty much wraps up the night. If you're here in the room, I forgot to mention that I am a CNCF ambassador, and what that means to you is that they give me lots of stickers. So I've got a bag full of stickers over there. If anybody's interested in pretty much any CNCF project, I probably have its sticker in my bag. I have $600 worth of stickers. I'm not kidding. It's a lot of stickers. So what's that?
Nice benefits.
Yeah. Nice benefits. I also have a lot of t-shirts. They ran a sale. And it was like $5 a shirt, and they gave me $250 in garb. So I have like every single CNCF project T-shirt as well. But I'm sorry, I'm not giving you those. But yeah, come see me. I'll give you some stuff. And otherwise, that's it for the night. We're gonna post more things on community.cncf.io under the Cloud Native Security Pittsburgh community group. Hopefully once every 2 to 3 months is going to be my goal to keep this going, and so they don't deactivate me again, because they were not happy that the last time I ran one of these was in September, and then now it's kind of too long. So I'm going to try to keep this moving. So maybe we'll
Sticker.
yeah, right, they're going to cut my stickers in half or something. So yeah, maybe we kind of take questions from the audience or like requests. I could try to get we have some people in Pittsburgh, myself included, where they can talk about some of this stuff, but I also know a lot of people in the community, so I could get maintainers of CNCF projects to jump on, and we could have an in-person component, but have the presenter remote and have remote people as well. Definitely open to that approach, and I can kind of facilitate getting the right people in the room. If we want to talk about observability, I can get some of the open telemetry team on the call, or Falco. We could talk about more like a Tetragon kind of competitor, eBPF security monitoring space, or any of the CNCF projects. So,
And I'll stay around in case you have any questions. If you're not in person though, CM Luciano, that is Kat, Matthew Luciano here, at isovalent.com, or you can find me on LinkedIn, Christopher Luciano. That's probably the best way to contact me if you have questions.
awesome. And eat some of the last pizza. So cool. All right. Thanks everyone. Have a good night.